This will be a quick reminder about all the transformations we did in Unit 5. Uh, remember, we always said that if it was happening outside the function, that was a vertical move, and everything was normal in vertical land, if you will. And if something happened inside the function, remember it was always going to be a horizontal move and backwards. So we look at this very first example. That plus 32 is inside, which means it's a translation, but instead of going to the right 32, it goes to the left 32. Here we got a negative x on the inside. Remember, negatives are reflection, so since it's on the inside, it's a horizontal reflection. The 4 on the outside would be a vertical stretch times 4. If we had to do this with points, since it's vertical, we would only touch the y's. Here we have a minus 2 on the inside and a plus 8 on the outside. Well, that minus 2 on the inside sends it to the right 2. That plus 8 on the outside sends it up, we'll send it up 8. Minus 7 on the outside is just down 7. The negative tells me I need to do a vertical reflection. And then that 6 on the inside, it's a horizontal move. And multiplying is always a stretch or a compression, but since it's on the inside, it's backwards. So that's actually a horizontal compression by 6. So it's going to get 6 times shorter, if you will, horizontally. So that would only be a move that affects the x's. Here, there's a compression and a translation. Remember, we always do translations last. So this is a vertical compression by 1/3. So it's going to get a third as tall, if you will, and then we're going to go up 6. Here we got 3 moves happening. You got that negative out front, so we can't forget about it. So we do a vertical reflection. Negatives simply reflect. Then we're going to go to the left 4 and up 9. If we want to go right 6 and up 4, so we'll go ahead and write the function down. So to the right 6 means we need to do x minus 6 on the inside, plus 4 on the outside. Reflect over the y-axis. So if we think about this, this is actually a horizontal reflection. I recommend writing that down because horizontal means that I need to do something inside, but I have a vertical stretch by 6, which means a 6 needs to go on the outside, and I need to put that negative in front of the x on the inside. Vertical stretch by 7 is just straightforward. Put a 7 in front of that. So reflect over the x-axis. Again, this would be a vertical reflection, which means there's a negative on the outside. So we go negative f of x, and then we're going to go down 5, so make sure that 5 is on the quote-unquote outside. Horizontal stretch by 2, then reflect over the y-axis. So that's a horizontal reflection. So to stretch it horizontally by 2, we actually need to do 1/2 on the inside. But not only that, we have the negative for the reflection. Left 6, down 3, so we've got the minus 3 on the outside. To go left 6, we need to say plus 6 on the inside. Reflect over the y-axis, so that's a vertical reflection. So we got the negative f. Right 6 means we need to do minus 6. Down 7 will be minus 7. Make sure we can do this kind of stuff with actual graphs of functions. Put my characteristic points in here. Anywhere it turns a corner. So my characteristic points, negative 1, 2, 3, 4, 5, negative 5, negative 1, negative 3, negative 1. Actually, I'll label these. I think I'm using my, that table's actually for the new points. So let me take a moment. A was negative 5, negative 1. B was negative 3, negative 1. C, negative 2, negative 3. D, negative 1, positive 1. E was 0, negative 1. And then F looked like 2, negative 1. So what's the domain and the range? So the domain, that's our x's, so we go all the way back to negative 5. And then we go all the way up to 2. That's just with x's. And then the range, how far up and down, so it drops all the way from negative 3 to positive 1. Make sure we put brackets. Transform the graph using negative 3x. Record the new point. So this is a vertical reflection. and a vertical stretch by 3. Well, vertical reflection means we need to multiply y's by -1, and the vertical stretch means we're not going to multiply y's by 3. All right, so let me clean that up just a little bit. The vertical reflection is just vertical, so that's y. Multiply the y's by -1, and then this tells me to multiply y by 3. So in other words, the x's actually aren't ever going to change. So I could put the -5, the -3, the -2, the -1, the 0, and the 2. I'm just putting my points in here. A, B, C, D, E, and F. Now really, if I'm going to multiply by -1 and by 3, I could just multiply all of my y's by -3. So I take this -1 in A times -3. That's 3. -1 times -1 is 1 times 3 is 3. -3, we reflect it vertically. That turns it into +3 times 3 is 9 now. So on and so forth. So -1, +1 becomes -1, -3. That -1 becomes +3. That -1 becomes +3. So I take a second, -1, -3. Oh, excuse me, -5, +3. There's A prime. There's B prime. -2, 9, 1, 2, 3, 4, 5, 6, 7, 8. There's C prime. D prime is at -1, -3. So there's D prime. E is now at 0, 3. And then F prime is now at 2. Excuse me, that should be 2, +3. So it's flipped this thing over, and it's made it really stretched out. So the domain and the range of the new graph. So the domain now, we're still going from -5 up to +2, right? All of our moves were vertical, which means the range is the one that's going to be affected. So the new range is actually going from -3 all the way up to +9. So if we wanted to record or transform the graph doing f of -x, that's a horizontal reflection, which means multiply the x's by -1. So if we go back up, the original points, -5, -1 becomes +5, -1. -3, -1 becomes 3, -1. So on and so forth, right? So -2, -3 becomes +2, -3. The next point, remember, was -1, +1 turns into 1, 1. 0, -1 stays at 0, -1. Right, we're just going to keep kind of picking through these things. And then we have 2, -1 turns into -2, 1. And I think I missed a point up there. I did. I missed the -2, -3. Oh, no, I didn't. But then if we think about it, really what's changed, x's are now going to go, are now going to change. So since we just multiplied the x's, the range actually didn't change. It's still going from -3 to +1 in terms of the x's. Now my new domain, if we look even in the x's, we can see that the x's are going from, now the lowest is -2 and the highest is 5. So we're going from -2 up to 5. And then if we wanted to graph it, we could just graph those points. All right, list the transformations that occur in the parent functions. So here we have a +2 and a -1. That +2 is inside, which means it's going to go to the left 2. That -1's on the outside of that little exponent thing, so that's down 1. Here we got a -2 on the inside and a +3 on the outside, so that -2 on the inside is going to send it to the right 2. And that +3 is going to send it up 3. Here we get that 2 on the outside, which is a vertical stretch by 2. plus 7 is going to send it to the left 7. And that plus 2 is going to send it up 2. So there's all your moves to the absolute value function.